The automated control of facades can be very beneficial if the control strategy is well developed. Francesco Isaia will help us now in this complex topic.
So, Miriam and I came here because we have a couple of questions about controlling and balancing performance in a facade, in particular the performance to heat gains and solar radiation, but also visual. So my first question is, how do you balance these two competing factors?
Mm-hmm. So thank you for coming here. And yes, when we talk about balancing solar gains and daylight, for example, we are talking about a problem with contrasting needs. And of course, it's something that does not have a trivial solution. And this is because when solar irradiance enters the indoor environment, it affects multiple physical domains. So we can imagine that it affects thermal performance and so thermal comfort of the users, but also the visual comfort of the users. And as a consequence, also energy needs for heating, cooling, and lighting the environment. So what factors, what do we take into account? How do we manage this complexity? Of course, we need to take into account the physical domains which are affected, but also the fact that these domains, for example, considering daylight, we have direct, immediate effects, so we have short-term effects. While if we consider thermal performance and thermal comfort, we have also effects which are delayed in time. If we imagine solar radiance coming into indoor environment, we have an effect which is delayed in time. So I brought these schematics to show you to a very simple example. You can see two cases. On the left-hand side, we can imagine, for example, in summer, that we let all the solar radiance through the facade into the building. So what happens here? It happens that we might be very happy with the daylight because we have plenty of daylight and we don't need to turn on the artificial lighting. But at the same time, the indoor environment is getting warmer, and in summertime, we might need to cool down actively the environment, so to spend energy for cooling. On the right-hand side, we might want to do exactly the opposite, so to block all solar irradiance. And in this case, we will be completely in the dark, so we need to turn on the artificial lighting, and also is less nice for the user to have not natural daylight, even though we are saving energy for cooling because the environment is not heating up. So it is clear that between these two extreme cases, we need to find a trade-off somewhere in between.
So from a technology perspective, how can we deal with these conflicts?
So technologically, we can think that if we deal with a static facade, we of course need to find a trade-off, a compromise, which is there for the entire year. So of course, it's going to be something suboptimal in many other seasons of the year. It's something globally, it's okay, it's a trade-off globally, but for many hours of the year, it's suboptimal to what we would like. So in this sense, I believe that using dynamic shading or dynamic facade technologies in general can be very helpful to really find the best trade-off for each hour of the day throughout the year in order to have the best possible performances.
Can you give us an example of a dynamic technology that we could design for a building?
Absolutely. We can go, for example, managing solar irradiance is often done through technologies like solar shading technologies, and we can go starting from very simple Venetian blinds that can be even motorized, and we can select the tilt angle and how much deployed they are, or even go up to fancier technologies like chromogenic glazing, electrochromic glazing, in which we can tint the level of the transparency of the glazing system in order to modulate the solar gains through the facade.
So if I understood correctly, the key point is that in order to avoid either maximum daylight but then overheating or good solar gains control but then lack of daylight, the best would be to have something that can change during the time and adapt hour by hour or day by day or season by season to the actual needs indoor, depending on the outdoor, right?
Absolutely, that's the key. And something that sometimes is forgotten is that user is also in the center and needs every user. We know that every user has its own preferences, but we can also imagine that the same user can have changing preferences over time because of, for example, the task is performing in the indoor environment. So being able to modulate solar irradiance through the facade gives us also the possibility to match what are the user preferences over time.
And as a designer, which are the components that an active facade has?
So, of course, we have components related to the solar gains control, so solar shadings, shading systems in general. We also can deal with ventilation control, for example, by opening and closing windows, not only manually, but also actively or through trickle vents or mechanical ventilation machines, which allow us to control, in this case, only the thermal part, also indoor environmental quality part in terms of air changes. So there are really many components, and each component can be as many technologies that can be implemented in each case study.
But, okay, there are the components that are inherent to the facade technology, but then because of they are automatized, are we adding something else? So you mentioned at some point the motors. So which are the components that we are adding to this system, the complexity we are adding, and the things that the facade engineering should know that if they go for an adaptive facade, they need to take into consideration in their design.
Yes, that's an interesting question. So the building is, of course, becoming more and more a complex control system. And I brought you another scheme here, in which you can see that nowadays buildings are really composed by multiple control systems which control many different aspects of our buildings. So, for example, just to provide a few examples, the heating and cooling system or electric system related to PV production or lighting system, but even fire safety and so on. And I think that shading and ventilation, so whatever is related to the facade, will become more and more part of a building's control system. So the actuators were the first component, and there is also this little brain represents the controller, which is the second and very important element in a control system. And what the brain does is getting the inputs from the sensors, elaborate these inputs, and there is an underlying logic under this brain which is able to understand which is the best solution to implement, and so sends a control signals to the actuators. And the actuators transform this control signal into a physical action. So there could be, these actuators might be motors that act directly on the lamellas, tilting them at the angle that we want, or it could be a motorized window that can open or close. It could be a ventilation machine that is activated or not. So I think that the facade engineer should know this concept and should be able to communicate with whoever designs the control strategies and the automation of the building in general.
Clear.
Now we can include this in our design developments.
Thank you.
Thank you.
Thank you. Thank you.